Okay, this is video 5 for the Gen 6 for the Corsair. It's going to need to be bored. Unfortunately, a couple of the cylinders, such as cylinder number 6 here, it's got some pretty serious pitting from, well, not serious, but serious surface pitting from sitting, and it is what it is. It's turning over really well. I'll discuss that in a second. Also, cylinder 1. If you remember in the video, yeah, look up in there. If you remember in the video, cylinders number 1 and 3 had just a horrific amount of rust in the intake runners. So, you know, did the damage. Yeah, you think. I'm thinking about something else. Otherwise, they're all in pretty good condition, but you know that means nothing if only one of them is bad. So, fortunately, the good thing is this is a standard bore. It's never been bored. So, 20, 30 thousandths. Typically, I'll just go ahead and go 30 thousandths. 30 thousandths will clean this up. There's a little bit of scratching in this cylinder as well. What is that? That's cylinder 8. But you know it'll clean up as well. I'm gonna see if I can. Before I forget, this is very important. And this is something I was thinking about a little while ago, and I thought I remembered the most important thing, but I had not. What I had in the back of my mind was assessing for hydrolock. When you go into an engine like this that you don't know the history of, and obviously you open it up and it's full of water, one of the first things you should think of in the back of your mind, did someone try to turn it over when it had any amount of water in it and created a hydrolock, which would warp a connecting rod? And that usually reveals itself when you get everything cleaned up and you start doing your rotational mass tests. And you do that, you know, with a torque wrench. You set it at about 20-25 foot-pounds, and then you just start kind of feeling of the engine, you know, as you go through it a full 360 through its rotation. It's amazing what you'll feel. If it starts jumping and chattering, that's typically, you know, rings catching on rusty pitted areas and things like that. So anyway, there's a lot of things that it could be, but where I'm going with this is I don't know if I'm going to be able to do this while I'm holding the camera, but when I do a rotation, I'm sorry, let me just put the camera. When I do a rotational mass test, I'm looking for that tight spot. See if I can move this side and show it. I'm not going to be able to. I'm not ambidextrous, but I'll pull through part of it with my left hand. It's real smooth. It's turning over really smooth. So that where I'm going with that is that's a very good indicator that it never hydrolocked. There are no warped or twisted connecting rods. There was no bottom end failure where bearings heated up and there's tight spots and things like that. So, and I'm serious. It'd be amazing. You'll feel 1/1000th of an inch if there's any amount of tightness in the bottom end. And this one's excellent. It's turning over really well. Unfortunately, that means nothing because it's obviously still a full rebuild and it's going to have to be bored. But for the most part, it's an excellent candidate. If this engine had already been bored, let's say it was a remanufactured engine and had been bored. See, look at the rust and the really nasty. If this had been a remanufactured engine and it had already been bored up to 40, I'd probably pull the plug on the job, or I wouldn't have taken it this far. The only reason I did so much assessment on this one is because when I discovered it was a standard bore, or likely a standard bore, when I started discussing the job on the front end with the client. So anyway, what else? Covered the hydrolock and the whole rotational mass test thing where you set your torque wrench to 20-25. This one's I think I'm set at 25, and it's turning over without clicking, and that's pretty cool. If it was tight, say around 30 foot-pounds, 35, even if it was up to 40, that's not the end of the world, but it's not healthy. In other words, it should be turning over. In other words, if you're in your boat and you pull the spark plugs out and you've got an engine that has been running, you should be able to put the torque wrench on your boat. Granted, keep in mind your raw water pump, there's a lot of grip there, and if you've got a bad water pump that might be tight, that'll give you a false reading. But if you're able to break the belts loose, in other words, loosen up all the belts, loosen the alternator, loosen the belts on which will loosen the belt on the water pump, and then even loosen up the raw water pump itself, which has the impeller in it. Then take a reading of the rotation of your engine, which I call a rotational mass test, and you will feel everything. Nothing can hide from that, especially when the spark plugs are out. You got to have the spark plugs out, and it should take about 25 foot-pounds of torque to turn that engine over properly. If your engine is 35, 40, 45 or higher, you got problems. It might run, but it's running under a hell of a lot of stress, if that makes sense. It ought to run under 20, 25 foot-pounds, and I think I've driven that home. So there you have it. It's ready to tomorrow. I'm not even going to fool with oiling these cylinders now, as I mentioned in the last video, because they got to get bored anyway. And there's a ton of WD-40 on them right now that'll hopefully protect what needs to be protected. So okay, that's the end of the night. Thanks, guys.